All right, so far we've talked with our last video. We talked a little bit about solids, liquids, and gases, the different physical states, and also the changes going from one physical state to the next, energy associated with those changes, exo versus endothermic, as well as the terms or the names that we use to refer to those changes that are occurring. Now, what we're going to we can use that to kind of jump out from a distinguishing or differentiating between physical and chemical, physical versus chemical properties. We've already alluded to, we talked about some of the physical properties. We didn't really call them physical properties at the time, but we'll be a little bit more rigorous with it here. And then when you see the term properties, this is just another way to refer to characteristics of substances of matter, if you will, and define matter, characterize matter, or several different ways of it. So, what's the difference between a physical property or a physical characteristic and one that is chemical? Well, in a physical characteristic or physical property, what we're looking at here is a property that can be a property or a characteristic that can be observed or measured without trying to turn that substance into something else. So, for example, we can say that um, the the sample of iron is brown in color. Well, that's obviously an observation, and we can make that observation without trying to change iron into something else. That makes it a physical characteristic. We can say iron is a solid at temperature. That is a physical characteristic or a physical property. Right? We're not trying to change anything else. We can say the temperature of iron is measured as 25 degrees Celsius. Right? That's just the temperature. You can make that measurement without trying to change it into something else. So those are physical characteristics of physical properties. Um, the that's in contrast to a chemical property or chemical characteristic. Chemical property can only be observed only when the substance changes into something else. Okay, so again, a characteristic that we can only observe or measure when that thing changes into something different than what we started with. So we can say, for example, we can say that gasoline is combustible. Okay, so that means it can we can only observe this when gasoline changes into something else. Well, what does it change into? Well, when you burn it, you don't have gasoline at the end, right? Um, we can say that iron is that's the chemical characteristic of it, and that occurs when that substance iron undergoes a chemical change, or undergo when it, I'm sorry, when iron changes into something else, for example, rust, it undergoes that corrosion process, right? So that's a chemical property, it's a chemical characteristic of a particular substance. So that's the main difference that we're looking at here. Physical property versus chemical. Can we make that observation without trying to change that substance to something else? If so, that's physical. If we can only make that observation when that substance changes into something else, that's a chemical property or chemical characteristic, which both of these then dovetail into physical versus chemical changes. And we talk a little bit about one of these properties. And we define what these are and look at some examples as well. So physical changes. Is a change that does not involve a change in the identity of the person. We looked at 6 of these before, so for example, melting of, let's say, ice, for example, it is nothing more than H2O water going from solid to H2O, the liquid. Yeah, there is no change in the identity of the substance. It's still the same pure substance, and that hasn't changed. What changes is a certain states. Or the liquid, you can think of any change in the physical state would be a issue. Still have the same substance, but yes, it's solid, liquid, or gas. So those are really simple examples. If you think of having a sheet of or let's say a nugget of gold. So this is a nugget of gold that we have here, and then we take a hammer to it and we pound it over and over and over again, and it turns into a gold sheet. But guess what? It still is gold. Right? What changes is the appearance of it from a blob onto a sheet, but it still is gold, so that's a physical change. Right? Similarly, you could take a piece of aluminum foil, split it into small pieces, but it's still aluminum. Okay, so that would be a physical change. Okay, and you can guess a chemical change is known in which there's a change in the identity of the substance. So, for example, a chemical change would be typically you think about maybe wood, maybe a piece of paper, and okay. Well, what happens when the wood of the paper burns? Well, it turns into it goes from a wood, not a wood, but wood or paper into some sort of ash. Right? And this is different than the wood that we started with. Right? Similarly, if you look at a piece of paper and you burn it, it's not paper at the end. It gets turned into ash, different than the paper that you started with. What did you change? Well, you drove off a bunch of components. Specifically, you're driving off a bunch of hydrogens and oxygens and whatnot, and you just end up with mostly carbon at the end, which is what that ashy thing is. It's the same idea when you think about burning anything. All right, so you can maybe that food, right? You eat the food, that's the fuel that the body uses, or what do you end up with at the end? Well, you end up breathing out a bunch of carbon dioxide and water, vapor comes out of your breath. And obviously, this is very different, right? Hopefully, you know this. The stuff that you breathe out is very different than the food that you ate. The reason why you eat food is to get energy. Energy is also released in this process that we take advantage of. And you can take that and extend it to the food or the fuel that your car uses. So gasoline, the different types of fuel. We don't eat or drink gasoline. That's the food or drink for your car, for your vehicle, right? But the same, it's made up of the same components and typical components that your food is. It just gets burned in an internal combustion engine, but the product of taking the food generally the same. You get a bunch of carbon dioxide and then yoga, which again is very different than the gasoline that you put in. That's why you have to refill your car with gas every so often because it gets burned, and as it undergoes that chemical change, it changes into a bunch of different stuff, like that are gases that gets released in the air, and then the gasoline gets used up. So those are the main differences between chemical changes and physical changes. So chemical change happens when there's a change in the identity of a substance. A physical change is a change where there is not an in the identity of a substance. All right, we'll do one more example. The chemical change we used, for example, up here, I think we talked about some of the physical properties of iron. Well, we also said that iron undergoes corrosion. That's a chemical property. Well, what's the change that occurs when iron corrodes? Well, the iron undergoes a process of corrosion to rust, for example. And that corrosion there is a process where it reacts with oxygen to make that rust. And that rust is very different, as you know, than the element that you started with, right? You have a rust bucket, you dump a rust bucket, you know that the rust falls off, you end up with less of a car as you keep driving, and that's because the iron, over the course of time, undergoes this chemical change. It's not iron anymore, it becomes rust, flakes off, and then your car weighs less as time passes by because the rust, which by the way is iron oxide, very different than the iron that or the steel, whatever it is that the car is made from. Very different, right? From what you started with to what you end with. And that's the hallmark of a chemical change. Change in the identity of a substance, physical change, a change that does not involve a change in the identity of a substance.